Welcome back. In the previous sections, we looked into different ways to build and customize your model and SCADA panel. Until now, we have run all of our models using Virtual HIL. Virtual HIL is a software module within the Typhoon HIL software toolchain that emulates a Typhoon HIL device on your PC in non-real time. Due to the software-based nature of Virtual HIL, there is no external I/O support. Simulating your model in Virtual HIL can be helpful for precise HIL device sizing, avoiding any surprises in your HIL purchase decision. To find out in which mode the simulation is running, you can find out in the right corner of HIL SCADA. As you can see, we are now in Virtual HIL mode. Also, let's quickly compare system time with the simulation time. We can see that we are not running the model in real time with Virtual HIL. Now, let's see how we can switch from Virtual HIL mode to real-time mode. First, connect your HIL device to your PC. His particular HIL device is connected using a USB cable. Now that we have turned on and connected the HIL device, let's wait around 30 seconds for the HIL device to boot. The process of booting is finished when the LED on the front plate of the HIL blinks twice. After this process, we can load the model again from within HIL SCADA. Now that the HIL is ready, let's go to the model menu and load the model. Now let's check if the HIL device is properly connected. To see which HIL device we is connected to and what time step we are simulating, we can always choose the Show Information About Loaded Model option in the model menu. If the model is running on a HIL device, the serial number and device name will be visible. As we can see, it automatically loaded the model to the real HIL device. Also, now in the right corner we can see that we are now in real-time mode. It is important to note that the model is already compiled. The model compilation process we performed earlier generates a file folder which can be used by Virtual HIL or a HIL device. This means there is no need to compile the model again when switching from Virtual HIL to a HIL device. If we compare the simulation time and system time, we can see that we are really in the real time. Also, we can see that LED on the HIL device is blinking, which means that the simulation is running. Also, let's take few minutes and take a look at the status bar in HIL SCADA. There are 2 SCADA flags and 6 HIL device flags. SCADA status flags are active in both HIL and Virtual HIL mode. The next 6 flags are HIL device flags, which are normally only active in real-time mode. The sole exception to this is the arithmetic overflow flag, which can be raised in Virtual HIL mode. The first one is the PSU fault indicator. It indicates the status of the externally available power supply unit. If you click on the PSU flag, a floating panel will open providing more detailed information about the power supply status and any faults. This flag is especially useful for simplifying troubleshooting when your controller board uses the power supply from the HIL device instead of an external supply. Next is the dead time violation flag, which lists the sources of any DTV errors. This indicates a shoot-through condition on any of the model's converter phase legs. If you click on the DTV flag, a floating panel will open, providing a list of all the latch DTV error sources. The arithmetic overflow indicator AO indicates that some values from the simulated model were out of the HIL device's numerical range. This may be followed by erratic model behavior. The arithmetic overflow flag is reset when the simulation is stopped. As we mentioned before, this indicator can be raised in Virtual HIL mode as well. Serial Link Status Indicator or SLD indicates that the serial link with the HIL device is down. The flag is reset when the simulation is stopped. Also, one very important status is Computing Interval Overrun or CIO. It indicates that the signal processing computation time exceeded the reserved time slot. The flag is reset when the simulation is stopped. Here you can see the system CPU and the user CPU signal processing time utilization. You can see that the user execution rate is 100 microseconds. You will find out more information about the CIO time slot monitor in the Troubleshooting Real-Time Models session. The Signal Processing Exception Indicator, or EXE, indicates that an exception is thrown by the generated code running on either system, user, or communication CPU. The flag is reset when the simulation is stopped. If you click on the EXE flag, a floating panel will open providing more detailed information about exceptions that have occurred. The next two flags are related to HIL SCADA panel. The Time Slot Overrun Indicator, or TSO, indicates that the HIL SCADA computation time exceeded the allocated time slot. When this flag is raised, it indicates that HIL SCADA cannot do all computations in the specified time slot, either because of the complexity of the embedded expression scripts, the number of widgets, or because of interactions with the rest of the GUI while the simulation is running. The Widget Errors Indicator, or WER, indicates that one or more errors occurred in some of the active panel's widgets. In this short session, you saw how to easily switch from Virtual HIL mode to real-time mode. You also learned about the key differences in the HIL SCADA environment when working with these two modes.